These are two RF amplifier boards I purchased from China via AliExpress. This one does not have an amplifier, it's just the devices to support the amplifier. This one has a Mitsubishi 57704 amplifier in its where this is empty. Now the one with the relays but no amplifier is actually a RF sensing board, and it's straight through. The output has no connector. Normally, when RF is sensed here, these relays switch the RF path. Instead of going through here to here, it goes into here, which is the input to the RF amplifier, comes out here and goes back into the relay. So there's a low power relay, high power relay that both transfer whenever RF is sensed here. This is the AliExpress sellers page. This thing cost me $15. And the specifications say input 1 to 5 watts, output 10 to 70 watts depending on this module. And I'm guessing the heatsink for the module. There is some note here about a plug-in resistor not welded, whatever. I don't see that. And if you compare the picture on the seller's page with the picture of the board itself, all the components are there, they're just in a different position. This little potentiometer is now a standard width potentiometer mounted this way instead of this way. And this little device has been switched around and mounted here. So I don't see any place to put this uninstalled resistor. This is the seller's page for this completed amplifier. That is a support board with an amplifier. This is a M57704. It costs $21. It has an allowable output, well, an allowable input power of 1/2 to 5 watts. Claims to be working over 410 to 470 megahertz. Claims to have an output power of 18 to 22 watts and a supply voltage of 10 to 13.8. Well, that's all well and good, but the amplifier itself, I'm assuming these are Chinese watts, 18 to 22 watts, because the 57704 is only rated 13 watts. And it has a narrower frequency range specified. Now that doesn't mean you can't operate the chip outside of the specified frequency. It's just that the Chinese people say we can go down to 410, while Mitsubishi says we can go down to 450. This board is the one with the relays, and the seller for this board says it will do 10 to 70 watts depending on the module. Again, Chinese watts, because the original manufacturer of this model relay was Fujitsu. Fujitsu says that this relay, well, both of them, they're identical, is rated at 10 watts. So I would hate to put 70 watt amplifier in here and switch it through a relay rated 10 watts. And the other thing about the relay is, you see this 9W as part of the part number? A 9WK has a coil voltage of 9 volts. I've created a parts drawing for each of these boards. The board for the RF sensing and switching, well, we've got an RF in, we've got our 2 relays, and they're shown in the normally closed position, the way they would be right now. The presence of RF is sensed by this D2 and C2, which convert the RF into DC, which drives this transistor, which turns on this transistor, which turns on the 2 relays and lights the transmit LED. At the same time, it supplies voltage to this LM317 and outputs a voltage to the first power input of the amplifier. And this voltage is adjustable by this 10K potentiometer. So 12 volts is always supplied to the second input terminal and the third input terminal. I'm talking power. That is DC voltage. So the first stage is not powered until this relay and the LED is energized and Q3 is energized. When energized, the RF goes through the relay, through a 3 decibel pad, and into the amplifier. Comes out of the amplifier and goes down to the relay, which is now the energized position, and it goes out. There's no BNC connector here. So that's okay. This amplifier looks very much like the amplifier without the input RF sensing circuit and relays. RF comes in through a 3 decibel attenuator and goes right into RF in. 12 volts comes in and powers the first amplifier and the third amplifier. There's an LM317 which is powered all the time from 12 volts. It outputs a voltage which is adjustable to the first stage power amplifier. And it's adjustable with 10K potentiometer. The only real difference between the 2 circuits is that this one has a 200 ohm resistor in it, while this one has a 2K resistor. I'm more satisfied with this than this, but we'll give the guy who designed it an opportunity. You notice the RF goes through an attenuator before it goes into the block amplifier. Same thing is true here. Same resistors even to the block amplifier. Now, this amplifier, not the whole board, the amplifier itself, the 57704, as we saw, is rated 13 watts. So what I intend to do with the game plan here is to remove this amplifier from this supply board and install it in this board. I can adjust this for a little less than the maximum output of 13, which may make these relays, at least this one, last somewhat longer. So I'll put this amplifier in this board. Now I need an amplifier for this board. Well, just so happens I purchased a 57788, which is rated 40 watts. So I can swap this amplifier, do the swap, and put this one here and here, and this will become a 40 watt amplifier. And this one, once I swap this amplifier, will become a maximum of 13 watts. Now, the data sheets for all this stuff, the seller's page from AliExpress, and my schematics will all be uploaded to a subdirectory to be announced below. As with most of my drawings, I try to date them. So if you're watching this video and you decide you want to bite on buying one of these, come back and make sure that you're viewing the most recent documentation. Before I can evaluate these boards, I'll first evaluate this one, which should provide 13 watts. But first I have to fix my spectrum analyzer, which has gone south on me. So if you're watching this video and it goes a couple minutes longer, it means I fixed my spectrum analyzer. Well, I've solved my spectrum analyzer problem, I think, differently than I thought I was going to. I've got this amplifier. This is the, of the two modules, this is the one with the packaged amplifier installed. The other amplifier has a hole in it where the brick is installed, and there's a few differences. It uses this 57704 chip, which according to the data sheet is a very poor data sheet. It was the only one I was able to find, however. It has an RF output of 13 watts and a supply of 12.5 volts. There are no relays in this amplifier, it's just a straight through amplifier. I got power hooked to it. I've never powered it up yet. And I've got some cables. I used a rather unorthodox method of settling my problem with spectrum analyzer by just going out and buying a new one. The new analyzer is a Siglet SSA3015X Plus. I debated on getting a Rigol, but this one had a much bigger screen and a much higher resolution display, and is advertised with a much lower noise floor. The difference was $300. Rigol was $1,000, and this one was $1,300. So I went the extra $300 and bought this unit. I've got the tracking generator connected to the sweep generator input. I've got the tracking generator also set to 0 dB. I've got about 6 feet of this little coaxial cable. I don't know what the number is. And you can see that the I'm sweeping from 300 megahertz to 1 gigahertz. You can see the maximum loss is almost 6 dB. But it's not linear. To take care of that, I'm going to store this reference which is a mathematical picture of this line. Then I'm going to turn normalize on. Does a mathematical computation and puts the line at 0 dB. I have the tracking generator now hooked to the input of the amplifier module. The output is being fed through a 20 dB 10 watt heat attenuator. I'll power it up and see what happens. Nothing happens. I've got two 20 dB attenuators here. The big one and the little one physically. So that's 40 dB of attenuation. This goes into the spectrum analyzer. And this goes to a Baofeng handy-talkie. The Baofeng is set at 406 megahertz. This marker is set to 406 megahertz. I'll key the transmitter, and you see we have an output of -5 dBm. Note the lack of spurs. I keep doing that, I shouldn't do that. Let me reset that. It's still -5. I'll disconnect this from the handy-talkie. Hook this back up. So the output now goes to the spectrum analyzer, and the handy-talkie goes directly to the input with no attenuation. Now we had -5 dB, 40 dB of attenuation. That gives me 35 dB of output power from the handy-talkie. And 35 dB is about 3.2 watts, which is about right for a Baofeng. I've got the power on, yes. Now we're going to see what the amplifier does. It has an output of -1, so it gained 4 dB. So we went from 35, or 3.2 watts, to -1, which gives us 8 watts of output. Now, I've got this set the whole way up to maximum, and when I key it, I draw more than 3.5 amps. I'm using a Hewlett-Packard power supply with an analog meter.